Hello everyone, welcome to the topic water. We all know how important water is for all of us, right? And we love to see water bodies like this clean, clear, blue, like this picture. So we have to do something to see our water bodies or water sources around us like this clean and clear. Before that, we have to know some important things about water. So what we have to know? Today, we are going to talk about the impurities in water and those impurities which create hardness in water. And we will learn how to calculate hardness of water sample. In the following lectures, we will see hardness determination by EDTA method. Then we will learn softening of water sample. Then biological oxygen demand and chemical oxygen demand, what they are, and definitely we will know some water purification techniques in the next lectures. So today we will learn how to calculate hardness. So calculation of hardness will be done by knowing the amount of impurities present in it. So definitely doing that, we will be able to explain hardness of water and we'll be able to differentiate between two types of hardness. And after knowing about hardness, we'll be able to judge the quality of water for different industry. So as I told, we all know how water is important for all of us. And you guys, you know that if we don't have enough water in our bodies, we will have different type of problems, like maybe we will feel drowsy, our digestion will not be proper, we'll have headache problem, will not feel energetic, right? So all these problems we all know day to day life. Here are some important things about water. As it says that, and we all know that only 3% of water which is covering the earth is fresh water, that is consumable water. And 1 of the 4 deaths of children under the age of 5 are result of water related illness. It says that 80% of illness in developing countries result from unhealthy water or sanitization system. So we can see that, but not only the developing countries, in developed countries like USA also, we are having water problem. If you will go to the sites shown below, you will see that in USA also they have lots of problem due to this contamination of water bodies. And see in this picture how this factory outlets is dumping their waste in water bodies, and this water then mixed with the sea or the other sources and then contaminate the whole water bodies. So what we have to do? Before learn how to calculate hardness of water, we have to know what is hardness, right? So hardness is about soap consuming capability. Means the water, how much soap it will consume to give leather or to form foam. So simply we will tell that hard water will consume more amount of soap to give leather and soft water will consume less amount of soap. So why it is so? Why hard water consume more amount of soap? So this cause of hardness is due to the presence of calcium, magnesium, iron, aluminium. Most of the cases this 4 and some other heavy metals also gives hardness. So calcium, magnesium, iron, aluminium, these cations are the cause for hardness. Why these cations are the cause for hardness? To explain that, see this reaction which is given below. This is sodium stearate. It's a simple one soap example. Sodium stearate, sodium salt of stearic acid. When it reacts with calcium chloride, it gives precipitate of calcium stearate. So calcium stearate precipitate out, like it's a white precipitate, so it will take out this fatty acid with it. So there will not be foam or leather formation. So that's the cause why the hard water which contains more amount of this salts like salt of calcium, magnesium, iron, aluminium, they consume more amount of soap to give foam. So as it is shown for calcium, it's same for magnesium, iron and aluminium also. So more the amount of this salt in water, more will be the hardness. Here is a scale to say the water, how hard it is, right? This is from World Health Organization, which says that we will call water sample soft when it is having hardness 0 to 60 ppm. So parts per million, what is this? This is in terms of calcium carbonate. So what is hardness? Hardness is soap consumption. The amount of soap it will consume. How we will find? All salts present will be converted into calcium carbonate. And we will tell hardness in terms of calcium carbonate. Parts per milligram or parts per million or milligram per liter. So it will be called a soft water if we have 0 to 60 ppm hard, 0 to 60 ppm of calcium carbonate in water sample. Moderately hard 60 to 120 ppm, hard 120 to 180 ppm, and very hard it is more than 180. So what is the disadvantage of this hard water? If we have this water with this type of salts in it, what is the disadvantage? Definitely it will consume more amount of soap to give foam or leather. It will be the wastage of fuel. There will be formation of scale in the metallic boilers. So whenever we boil this type of water, we will have formation of scales. This white precipitate settles down on the inner surface of the boiler and it gives stable scales. And what will be the problem? There will not be uniform heating. Next case, we can say that there will be a problem of strength of concrete. If we use this type of water for concrete, the problem will be the strength. Most affected industries are textile industry, sugar industry, paper and pharmaceutical industries. In textile industries, we have lots of colors, right? And then if we have this type of ions or this type of salts in water, they will give problem. For sugar industry, crystallization of sugar will be affected. For paper industry, again the printing of paper and the stability of paper will get affected, and definitely we know pharmaceuticals, everything should be so pure, right? Solvent or whatever, reactants, everything should be very pure, in pure form. So definitely we can't use hard water in those cases. So the next question is how much hard? How we will calculate hardness. So all hardness producing salt should be converted into equivalent amount of calcium carbonate. Why calcium carbonate has been chosen? Simple, the molecular weight of calcium carbonate is 100, and what is the equivalent weight? Equivalent weight of calcium carbonate is 100 by 2, that's number of electron transfer or valency of calcium. Then the equivalent weight of calcium carbonate becomes 50. So I think you remember equivalent weight. What is equivalent weight? Equivalent weight or gram equivalent is the mass of a given substance. It's expressed in gram, which combines with or displays a fixed quantity of another substance. So we want to know that how much amount of soap will be consumed, right? Why the soap will be consumed? Due to the presence of this type of salts. And every salts will be converted to calcium carbonate. Why it is so? Because as an example, if we have 25 gram of calcium chloride in water, 25 gram of calcium chloride will consume some amount of soap, that equivalent amount of soap. But the same time 25 gram of ferrous sulfate definitely will not consume that equivalent. It will consume the equivalent amount of soap of 25 gram of ferrous sulfate. It's not equals to 25 gram of calcium chloride. So everything has to be converted to one equivalent salt that has been taken as calcium carbonate. Got the point? So while during hardness calculation, all salts should be converted into calcium carbonate, equivalent amount of calcium carbonate. Before calculating hardness, we should know there are two types of hardness. We say one is temporary hardness and another one is called permanent hardness. What is temporary hardness and what is permanent hardness? It's simple. Temporary hardness is carbonate and bicarbonate of calcium, magnesium, iron, aluminum and other heavy metals. Why it is temporary? Because this temporary what comes, it can be removed easily. It can be removed by boiling. Whereas permanent hardness cannot be removed by simple easy process like boiling. It can be removed. It requires some extra effort like ion exchange method or something else. So temporary hardness is a simple one which can be removed by boiling, and permanent hardness is little difficult to remove. So what are the cause for temporary hardness? Carbonates and bicarbonates of all these cations are cause for temporary hardness. And permanent hardness like sulfate, chloride, nitrate, all the salts of these cations are cause for permanent hardness. So let us see how temporary hardness can be removed. Here are just simple two examples. Calcium bicarbonate. Why we are heating calcium bicarbonate? Calcium bicarbonate gives calcium carbonate which precipitate out, and we can easily remove this calcium carbonate from water. So calcium bicarbonate precipitate out as calcium carbonate, whereas magnesium bicarbonate while heating it gives magnesium hydroxide precipitate, and we can remove again this magnesium hydroxide precipitate. So you have to remember calcium bicarbonate is removed as calcium carbonate, magnesium bicarbonate, whereas magnesium bicarbonate has been removed as magnesium hydroxide. Whatever it is, by boiling these salts precipitate out and we can easily remove them from water. That's why they are known as temporary hardness, whereas for permanent hardness this is not possible. So now you know what is the cause for temporary hardness and what is the cause for permanent hardness. Let us calculate hardness and for this type of numericals, and then when we will discuss this numerical we will be able to understand how to calculate hardness. So what has been given? A sample of water is found to contain the following dissolving salts. What are the salts? Magnesium bicarbonate, which is the amount of magnesium bicarbonate is 73 milligrams per liter. Calcium chloride 101 milligrams per liter, calcium bicarbonate 81 milligrams per liter, and so on, so on. So we will see one by one. So what we have to do? We have to make a table like this for easy understanding. We will take name of hardness causing salt, then we will write the amount of hardness causing salt given, and then we will see what is the equivalent weights of this hardness causing salts. Then we will convert all the amounts of this hardness causing salts to the equivalent amount of calcium carbonate, and lastly last column says which type of hardness these salts will produce. So first we will start with magnesium bicarbonate. It has been given that magnesium bicarbonate is present 73 milligram per liter. Magnesium bicarbonate is present in this sample. Now the equivalent weight of magnesium bicarbonate, to calculate equivalent weight we have first calculate molecular weight and then we will divide it by 2. Magnesium plus 2, right? So divide by 2. So the molecular weight of magnesium bicarbonate, that means the atomic weight of magnesium plus atomic weight of this bicarbonate unit multiplied by 2, all this, when we calculate this, we will get 146. And then equivalent weight of magnesium bicarbonate is 73. So now let us calculate the 73 milligram per liters of magnesium bicarbonate is equivalent to how much amount of calcium carbonate. So how we will do that? The amount present divided by the equivalent weight multiplied by the equivalent weight of calcium carbonate. So every time what we will do? We will take the amount present divided by the equivalent amount of the salt and multiplied by the equivalent weight of calcium carbonate, that is 50. So here it is 73 is present and then divided by the equivalent weight of magnesium bicarbonate, that is again 73 multiplied by 50, that gives 50 milligram per liter. And what type of hardness it causes? It causes temporary hardness. The next come calcium chloride. The amount of calcium chloride given is 111. So, and again when we will calculate the equivalent weight of calcium chloride, it is molecular weight of calcium chloride is 111 divided by 2, that means it is 55.5. So the equivalent amount of calcium carbonate due to this presence of calcium chloride in the water sample is 100. So this way we have to calculate the equivalent amount of calcium carbonate for all this present salts. So here we will write the type of hardness also, which cause temporary hardness and which cause permanent hardness. Now it's clear, right? Calcium chloride, why it is permanent hardness? Because chloride salts of calcium, it is caused permanent hardness. Again, please remember, carbonate and bicarbonate of calcium, magnesium, iron, aluminium, these are all cause for temporary hardness. So whenever we will see bicarbonate and carbonate, that is a cause for temporary hardness, and the other things, chloride, sulfate, nitrate, these things of calcium, magnesium, iron, aluminium is a cause for permanent hardness. But please remember, the cations are cause for hardness. The calcium, magnesium, iron, aluminium, most of the cases for your numerical, calcium, magnesium, iron, aluminium are the cause for hardness. So if we say that we have some amount of NaCl in this water sample, but NaCl doesn't give any type of hardness, it is not comes under this category which causes hardness. This cation, we have seen now that sodium stearate is a soap. So if we have NaCl, nothing will happen. Now precipitate will go out. So sodium, like potassium, all this, whichever cations does not give hardness, those cations you don't have to consider for hardness calculation. Only calcium, magnesium, iron, aluminium. Okay, so whenever we will finish all this calculation, what we will do? We will add up all this equivalent amount of calcium carbonate, all temporary hardness we will add up, and here for this numerical, temporary hardness is caused by magnesium bicarbonate and calcium bicarbonate, and we have seen here that equivalent amount of magnesium bicarbonate in terms of calcium carbonate is 50, and for calcium bicarbonate also equivalent amount of calcium carbonate is 50. So 50 plus 50, temporary hardness is 100. And for permanent hardness, we will add calcium chloride, magnesium sulfate and magnesium chloride, which is total 233.3 milligrams per liter. So this is the way we have to calculate hardness for a given water sample where we know the amount of impurities, means hardness causing salts, the total amount means all hardness causing salt, the amount of hardness causing salt will be given, then we can calculate the hardness. So after this lesson, I think you all will be able to calculate hardness of water sample by knowing the amount of impurities present. You have now a concept of temporary and permanent hardness. What is the cause of temporary hardness and what is the cause of permanent hardness? And definitely we have the concept of hardness of water. Here is a small assignment for you all. So the first question says distinguish between temporary hardness and permanent hardness. Most of the cases the marks will be given, 3 marks will be given for this type of question. And then here is 2 example where we will calculate different type of hardness when the amount of salts has been given. So please do that. And see here in problem number 3, it has been given sodium sulfate, presence of sodium sulfate. Please remember that we have to only consider the hardness causing salts. We don't have to consider those salts which will not produce any hardness. Thank you. Thank you for listening.